All right, well, happy Monday, we made it back. So we have exceptions and modules. So exceptions is a really fun topic. Modules is like 2 pages and really quick. So should go relatively quickly for us. There's a lot I want to do with exceptions, so it'll probably take all of today to talk about exceptions. Modules on Wednesday then will be pretty short. There's not a whole lot there. I don't think we can jam it all in. Maybe we can jam it all in today. We'll see how fast it goes. So it'll give you a little more time to work on project 3. And then next week we'll get to our final project. We should have a lot of fun. So we'll be incorporating files into the final project. And then go off on Thanksgiving break. If you want to take the break, great. If you want to work ahead, whatever works well for you, that's fine. Just make sure you get some cranberry jelly. It's the good stuff for Thanksgiving. Then again, we'll touch on some of these topics. We don't go super deep into them. So we'll spend a little bit of time on inheritance recursion. We'll spend a little bit of time on some fun Python for data science stuff. And then final project work time. I have no plans to lecture. I'll just show up. I can answer your questions. Ideally, you work in pairs for the final project, but you don't have to. It's not a requirement for this class. Next class, it will be a requirement as we get into adding group work as a learning outcome, that sort of thing, and learning how to collaborate with code. So I recommend it, but you don't have to for this one here. So we've got a little bit of time to work with your partner if you want. And then we'll probably be in this room. They haven't released the schedule yet, but usually you do finals in the same room unless, I don't know, stuff happens. So that's about the end here. We're getting pretty close. Sorry I missed you Wednesday. Hopefully the video on unit tests went well. Was that okay? Okay, cool. Oh, I didn't put it in the list here. Did I put it in the list? I did, okay. I added to the list for people. So we're gonna look at how we can use exceptions. So far with classes, when bad things happen, we don't really have a lot of options, right? Like, hey, if you tried to drive your car more than you had fuel for it, we return false or something. We say, oh, nope, we return the value, but it doesn't really make you do anything here. So what exceptions allow us to do is force the person who used our code to do something about it or crash. So we've seen exceptions before, like when we try and do silly things with user inputs. Let's see, where's none of those were user. Let me start a new. This will be, is this chapter 10? Was that it? Books. I think it was 10 for exceptions, right? Those 9 was classes. Yeah, 10 for exceptions. Chapter 10. Chapter 10. Exceptions. Why does this seem dark? Am I writing this down? All right. So we said, hey, maybe I wanted, number was an int of an input of please enter a number. And we enter 10, and it crashes on us. This here is an exception. Something bad happened, something exceptional happened, and our program didn't handle it, so it crashed. So if you don't handle the exception, your program crashes. And this is why anytime I deal with apps that crash, it just pisses me off to an unreasonable amount here, because they should have just handled that exception and not crashed. But sure, that sort of thing. Some developers get lazy, and that's okay. It's always a trade-off here with how much time we wanted to put into things. So it'd be nice if we didn't crash, right? Well, it turns out we can do that. So we can do something called a try block. So if we know something might crash, we can try it. We can say try and have a block here. And at the end of this, what we're going to do is we're going to catch and say, hey, except. Sorry, that's a other language. So try, if there's an exception, if an exception happens, I want to deal with it here instead of crashing. So I can say, hey, accept a value error as E. As E. So if a value error happens, I want to deal with it in this code block. I'm going to call it E. So for us, we're just going to print E here. And then now we can continue on to do something. So I might maybe say, number equals 0. So you put some sort of value here, and now we can print number at the end. So if we enter a number, we enter 10, no exception happens. This block of code never runs. If there's not an exception, we never get here. We only get to this block of code if an exception happens. So we were able to print number, no problem here. But if I enter 10, I'm going to jump to this block of code here. So as soon as the exception happens, you jump to your except block. So if there's other code here, and maybe we print is a valid number, right? That line of code will never run because we're going to jump right from here. An exception happened, and Python says, hey, is there something that's going to handle it? Is there an except block that I fit into? Is there an except block that's looking for a value error? Yeah, okay, I found one. Let's do what that one says. And we can print E. E is the exception message here. Right? So we're catching the exception. So we can give them some sort of message. And I just defaulted number to 0. I wanted to give it a value so that by the end of this block of code, number has something here, whether or not it's 0 or not. Now, it's not super useful here. So what a lot of times people will do is they'll do something silly, which is okay. It's all right. We'll say while true, do this. And if it works, we're going to break out of our loop. Now I know we need to set number to nothing. So forever, until I hit break here, keep on trying to get number. Eventually I'll get a good number here and I'll break out of my loop here. If not, I'm just going to keep telling them, hey, invalid literal for int base 10, 10. Now this is probably not the most friendly error message. You might not want to print the exception here. Or sometimes you print the exception and then you print another message or those sorts of things. Like you might see, hey, here's this really weird error code. It's not super helpful for most people, but they're like, hey, you could report this to somebody. Somebody probably knows what this error code is, but here's a message, that didn't work, try again. So now we get a nice little loop here. Hey, we can enter 10 or gibberish here, but as soon as we enter a number, we're done. So this lets us get a number despite whatever they enter. Right? So we're not going to crash now on invalid input. So being able to handle exceptions and do these try except blocks is super handy, right? Because no one likes a program that crashes, right? That's just, it ruins everybody's day. Probably shouldn't actually ruin your day, but you can feel irritated that their program crashes because they could do better. So this is the try and accept block, which is cool. Now, the other thing that we might run into, you can have multiple kinds of exceptions here, right? So I think the next example here they did like result is number divided by number, I don't know, something silly like this. And if we enter 0, 0 is a valid number here, perfectly fine, it will convert here. When we try and divide by 0, we get a 0 division error. Who knew there was an exception for that in Python? You guys run into that one yet? Probably not. That's okay. So there's a 0 division error. So our except block here doesn't catch that because we only deal with value errors, right? So it ignores it. It doesn't fit. So essentially the exception happens and we say, is there a place that this fits for us to deal with it? And it doesn't fit in value error here, right? So we can, if we want to have a second except block, let's say 0 division error, as E, and we can print E or something like that, sure, and handle it differently. I mean, this is doing the exact same thing. So this feels bad to have the same code here, right? But this would handle our 0 error. Division by 0, now that's not super helpful here. Like, what does that mean? Again, give them some sort of useful message here. The other thing we can do is we can catch, I think it's capital E exception? We'll catch literally every exception here. Now, there's reasons this works, but we don't get to those reasons until we get to the inheritance chapter. So don't worry too much about it here. But essentially, any exception is a type of exception. Right? All those special subtypes of exceptions are still exceptions. We haven't really delved too much into what inheritance is. We'll get to that later. So you can catch them all here. It's a little risky to just catch a generic exception, depending on what we're doing. Right? So we know there's only like 2 things that can go wrong. When you're dealing with really interesting, complex things, and we get into dealing with files, we get into dealing with all sorts of other things, it's a little bit too broad. So you want to be careful using a broad exception handler. For our purposes, we'll probably be okay. But if you can be specific, you want to be specific. That's generally the best one there. Okay? So we can do these try and catch blocks with exceptions. They're super cool. So that's, excuse me, handling them. The other thing we get to do is we get to use exceptions. And this is where it's really fun. So when we have a class here, so let's go write a class. Let's do, how about cup? Class for cup. So we're going to define our init method here. And then our cup probably has a maximum volume, right? And a cup will probably always have that maximum volume, right? So that if it's immutable, if we don't want that value to change, I'm not going to give them set methods. I'm going to ask for the value in the constructor. Hey, when you make the cup, tell me this is a 24-ounce cup. I don't know how many milliliters it is offhand. I'm sorry. All right, I'm going to Google it now because I want to know. 24 ounces, 2 milliliters. 709. So this is a 700-ish milliliter cup. We'll just round here because that makes life easier here. So this will be maximum volume in milliliters. Is there 2 L's there? There's probably 2 L's. Milliliters. There we go. ML is probably okay there. But again, I'd like to be obnoxious about it, and I will spell literally everything out every time, just until you get used to it. All right, so that's probably fine. So we'll set our self dot. Now I'm going to put a little underscore here, right, to make this mark it as private. Don't go change this one on me here, because bad things will happen if you do that. We'll set the max to the max, and then we'll set a current volume. Again, I want to make this one private. Current volume in milliliters is 0, right? You didn't put anything in it. Okay, and then things you can do with the cup. You can try and drink from the cup. So we're going to define a drink function that takes a milliliters to drink. And then we're going to try and remove that much volume from our current volume. Right? When you drink out of your cup, you're removing volume. So we'll take our self.current minus equals the milliliters to drink. And then we wanted to make sure we didn't go out of bounds. So, or maybe we want to do this check first, right? So how about we can say if my milliliters to drink is greater than my self.current volume, right? If you try and drink more than you have, well, we want to tell them that is bad. So to cause an exception to happen, right? If we wanted to say whoever used this code, either handle this or crash, right? That's the forceful way of telling them they did a dumb thing, you did a bad thing. You say raise, and we can say value error probably. So you can use all sorts of types of exceptions. There's a ton in the Python library, and then we'll learn to make our own eventually, if you so care to make custom exceptions. Some people really love custom exceptions. Some people just use value error for everything. Again, I'm lazy because I'm a good programmer, so I'm just going to use value error for everything, right? At some point, it's fun to do your own custom ones, but this is fine for now. And then in here, we can give it a message, like there's not enough in your cup or something like that. Not enough current volume. If you want, this message part's optional here. Okay, so you can drink from the cup. So if I want to make a cup here, so cup equals coffee, given, I'm sorry, this is a cup, here we go, coffee equals a cup. And then we'll tell it maybe the max is, what do we say, 700? And then I want to take coffee.drink. I want to drink from my coffee here. I want to drink, I don't know, 10 milliliters? That's 2 teaspoons, right? 15 is a tablespoon. That's probably a good drink, right? A tablespoon. We'll drink from our cup here, and now it crashes. It says value error, not enough current volume. Right? We can crash our own program, which feels like it'd be a silly thing to do, but what this means is now instead of just like returning a false or just setting the volume to 0 and hoping someone notices somewhere, right? We're being forceful about it and saying, hey, you tried to do something that we can't do, go fix it or crash, right? It's totally up to whoever uses it. And as our programs get bigger and bigger and bigger, and we're able to break these into more pieces and we have more pieces to solve, programming work becomes more team-based. You need more than one person working on it here. So maybe I'm just working on the class here for cup, and someone else will be working on the part where the user actually interacts with this thing here. Right? Maybe it's our coffee dispenser, and it, we'll automatically dispense a certain amount of coffee or whatever nonsense we want here, right? And if they try and take too much out of it, it's going to crash. Right? We want to make sure that they're forcefully dealing with these things here, so we can use exceptions to make sure that they handle the bad thing. Right? And if you get to raise, then the code stops. It's kind of like a return. Your code just stops at that point. So I don't even need an else here. Like at this point, I can just take my self.current and I can subtract from it the milliliters to drink. Right? And then I forgot, because we have these private attributes here, we need to give them public methods, public functions, to get at them here. So we want to get current volume in milliliters. Forgot to finish the rest of this here, and then we can return self.get self.current current volume and a get maximum volume in milliliters. It returns self dot max. Okay, it's a little bit tedious to write these things. This is really good to get ChatGPT to write. Like, hey, here's my init method, write me a bunch of gets. That's that sort of thing. It'll generate those for you. Really nice. Like here, we can go ask it. GPT. Please write the get methods or get functions for the attributes of this class. And you like paste in the init, and it's pretty good at figuring it out here. The spacing gets a little weird. But now, hey, look, I've got two get methods here, right? You don't need to do the typing yourself for get methods. It's super boring, right? It's not a typing class. So like, this is great. And again, if we're going to cite our source here, right, I could say, hey, right above my methods here, let's say, GPT, and here's my prompt was this. Look at that, and even like put it all in for me. Look how handy that was, right? So we've cited our source, and I didn't copy paste those. I guess we should copy paste them. Now, is this a useful comment for you? Do you find that useful? Getter function for maximum volume in milliliters? No, that's not a helpful comment in ChatGPT. It's trying, but nobody writes these, right? So if you have these in your code, I know you didn't type it out. It's pretty obvious, right? Because I've never told you to write these things. No one's ever told you to write these things. ChatGPT writes these things because they're dumb. And it's just a dumb computer doing dumb things, right? Okay, sorry, go off on tangents. But, well, sure, we'll copy paste it in because why not, right? Now we have it commented in, right? So that's what you're gonna do, right? We're not asking it to solve our entire problem. We're having it do the easy things for us here, right? All right, and again, here's the prompt we used. If you're using the OpenAI version, you can give me the URL to the conversation. That saves you a little bit of copy pasting work, and I can see your whole conversation. I like that too, but the UMGPT is a pretty good one too here. And our U of M team has trained this one. It's version 4.0 or whatever now. I can't even keep up with these. They seem to be changing every week. So, all right, so here's our cup class, right? So we can raise our own exception. So same idea if we go to fill. So I want to fill my milliliters to add, or to fill, I guess. Add, pour, I don't know, what do you want to call this? Add, fill, we'll stick with fill. So if it's going to be too much, we should raise an exception, right? But too much then is going to be if my milliliters to fill plus my self.current is greater than the self.max, right? You have to be a little bit careful with that arithmetic, right? Is the amount you're going to add to the current volume more than the max, not just is this more than the max? Because we can't assume the cup was empty, right? If it is, then we can raise a value error that will overfill, cup will overflow, something, I don't know. Otherwise, we can go and do it. So we'll take our self.current volume in milliliters plus equals the milliliters to fill, right? So now our cup now is going to protect its integrity, make sure we don't get into a bad state here. And now we chose at this point to say with drink, like, hey, we're not just going to stop at 0. We don't even make the change at all. If you try and drink 50 milliliters and there's only 10, no drink happens. Right? That's just our choice here. That we could decide to do that, or we could decide to say, hey, okay, we'll let you drink it down to 0, and then we'll raise an exception. Totally up to us. However we think we want this class to act, we get to write the code for it. So that's just a choice we get to make here. Right? So we still could say, okay, you drank all of it, or you filled it all the way up to the top, and then we just raise an exception to make sure you didn't overfill. Right? That sort of thing. Hey, if you're filling a gas tank, don't put 50 gallons in because you'll spill a bunch of gas everywhere. Right? Maybe just stop. It's just a choice we have here as we're working with it. So those are our raising exceptions. Okay. Another thing we can do is we can use this finally block. So this one doesn't make a whole lot of sense for us here, but you can add a finally block that runs no matter what happens. So try if an exception happens to go to accept, and then the finally block will run here. So in this one, excuse me, they have RDnums? I don't even know what RDnums is. Open up, why are they doing files? We didn't get to files yet. This stuff is like weirdly out of order here, I'm sorry. So if an exception happens, do something. If an exception happens, do something. Finally, go and do something else where they close this thing here. Sure. Okay, no, that was not a very good example here. How about our result here? Result, if we're able to calculate a result, we get a result here. If not, our result will be -1, which is kind of weird, but sure. It will finally print result is -1, right, with our finally block. You can do some cool stuff with finally blocks. They're not super, it just depends what you're doing. When you work with files, making sure you close your file is really important. So this is a pretty common use, but we haven't got to files yet. When we get to files, we'll look at that, and it'll make a little bit more sense here. So like I was setting number, right, to like 0 inside of the exception at one point. You could do that in a finally block, but you wouldn't want to change number in the finally block necessarily. Like you could do your results, or that one's a little weird. Explain with AI? Is AI going to explain what's wrong with my code? I think this is one of their trial things, right? They want you to buy the premium features, right? So if you take AI and jam it in your product, now you can sell it for like twice as much money, I hear, because your product now has AI. Have you seen that joke? And like all the AI stuff is just callbacks to OpenAI, GPT? No? Okay. Some people maybe. All right, cool. Actually, this is going a little better than I thought with exceptions. We're cruising along here. Let's see, that exceptions with functions. Yeah, that's what we were doing with our own functions. Yeah, so with our own functions, we're raising exceptions. That's great. Finally, to clean up, what's that last one? Custom exceptions. Again, we haven't got to inheritance yet, so this doesn't make a whole lot of sense, but you can make your own exceptions this way. It uses inheritance. We'll look at that when we get to inheritance here. If you like, hey, this is a less than 0 exception, and you can have a specific type of exception that you can now catch as that specific type of exception. Just gives you a little bit more flexibility sometimes if you want to be very specific about things here. Awesome. Wow, that went quicker than I thought. Yeah, raising exceptions. Let's see, did we get them all? We did our try and catch block. Multiple handlers, we did that. Try, accept, accept, accept. Yep. Yep, still good. Okay, you can also comma separate the ones that you want here. You say accept as like, and you give it a tuple of exceptions, so you don't have to have the exact same line twice, rather than just catching exception. Or just a regular accept will catch everything. That's right, Python's handy like that. So we could just say accept. We don't even need to specify the type. Now, if you want to handle it though and be able to print it out, you need it here. But if you just want to say accept, here we'll leave this one commented maybe. We could say accept, print, error, try again. Isn't that right? Accept. Oh, it's just warning me it's too broad. It's giving me a warning saying, hey, you're catching everything here. But again, you've got that option if you want it. Oops, we can't drink from our coffee cup. We got to fill it first. Let's fill it for 100. Now we can drink out of it. Enter a number, 10. Oh, we never got our error. That's right, we were supposed to do 10. There we go. So it does still work. It catches everything here. But again, it's super broad. And then there's no error message to print if you don't handle it and say, hey, I want it as something, and kind of give it a name with this little as handler here. Notice they don't do the as handling. I don't know why. I prefer to see what that error message is. I guess if you know you caught a invalid, what was the invalid input exception, like you know you didn't enter a number, that sort of thing, I guess you got some options. But all right, cool, that one's good. Raising exceptions, we did, yeah, so printing is definitely not a solution here. I don't think I spent enough time, when we worked on classes here, the goal of a class, when we talk about this encapsulation and abstraction, is we want it to be a nice little package that doesn't care where it's used, right? If the only thing our class does is deal with prints and inputs, we can't use that class anywhere else other than at a console application. And I don't know the last time you guys actually used a console application was. Probably never, maybe, right? So the class should be independent of input and output. So it shouldn't ever print anything. Classes should probably never print, unless like that's the only thing it's designed to do. And classes should never use input here. If you want values in your class, you should have functions that take them as arguments. So what this lets me do is I can take this nice little cup class and I can use it in a web application. Not that cup's very interesting, but I can put it and a web server can go talk to it and use it. Because if you're printing something out on a web server, no one's ever going to see your print messages. So it's especially bad to print errors and say, hey, you entered a bad thing here just as a print. No one's going to see it, right? It shouldn't do that. So that's why we want to use exceptions, to be forceful about it here, so that I can use my class in other places here. So I want to be separate from my inputs and outputs, right? So classes should rarely ever deal with input, keyboard input, and should rarely ever print, right? For our purposes, it should never. We're not going to do that in our classes here. We're going to have the rest of our code, like the rest of this main section here, our main Python file, can deal with user input if we want user input. When we start working with files, I can start reading things out of files using my classes, right, and doing something with it. Much more interesting here. So that's a reason to avoid using your prints in your classes here. So the exceptions are handy for that. All right, awesome. Yeah, I think we can move on to modules then. That's sweet. So we'll try exceptions in our lab here when we get there. So, okay, they added a little bit more. So modules are really cool in Python. We've used modules before. Like when we say, I want to import random, we're using modules. So random is the module here. There's actually a Python file out there named random, random.py. So a module is just a Python file. Right? So we can go out and look, where's our Python installed here? I think I've got my virtual environment. Is it in here? I don't, oh, where's Python installed? I've got it in here somewhere. I think it's in like app data or something. C, users, Eric C, app data, local. Oh goodness, it's in here somewhere. Let's see. When I go and set up my Python environment, if I can find it. This one, project interpreter. Here we go. C, users, app data, local programs, Python. Okay, I almost had it memorized. Programs, Python. There it is. Python 3.12. And then in the lib. There we go. This is the Python library. These are all things Python libraries. In here we should be able to find PQRS R random. Here it is. Random.py. This is the random module in Python. We can go ahead and open this one up. How about like VS Code maybe? That'll format it nicely. Goodness, thanks VS Code. It's a little small. Where's my zoom? Oh, goodness. View. Appearance. Zoom in. Okay, control equals? Sure. How's that? Is that a little bit better? Okay. I don't know why this one wasn't hooked to the mouse wheel. That's weird. So this here is a big comment block, right? We don't really use them a whole lot, but they've got some nice purposes here. So it's telling us about these things and what they do, and telling us a bunch of fun things here. One of the most extensively tested generators in existence. The random method is implemented in C, executes in a single Python step, and is therefore thread safe. That's a fun note here. Translated by, from C, source, provided by, adapted by, for use with the Mersenne, Twister, and OSU random core generators. Wow. That's some fun stuff. Here's all the things it's doing. Wow, that's a lot of fun math stuff. Sure. All right. Here's the random class. It sets itself up. Here's the seed value, right? That it says. Remember, we can set the seed if we want a very specific sequence of random numbers here. We'll get to one in here eventually. Let's get state. These are all like hidden ones. These are private functions here we're not supposed to mess with, but they do exist, right? Random below without get random. What? My goodness, I don't even know what all this stuff is. Random range, it's close here. Choice. Oh, we did a choice before, right? Look, it's getting the sequence of a random number below the length of the sequence. Random number below, that's that little helper method we looked at, random below. Where's that? I thought it was up here. Wasn't it up here? I guess it wasn't. Oh, it's just a random, okay, that's up there. This is fun, right? Shuffle, we need to shuffle something and we'll go and pick a bunch of random values here. We can sample. So these are the comments here. So when you define a function, you can give it that comment block. Remember, that's what pops up when you go and open up the method. Oh, like hover over the function. So if you go to sample something, we say random.sample, we get that little helper text. Right, so I want random.sample, sample something here, and I hover over sample. That's what shows up here, right? Chooses k unique random elements, choose k unique random elements. So these doc comments are super helpful if you're building a library for someone else to use. Super helpful. I generally skip over them because they're a waste of our time, right? If you're going to go build a library, great. You can go, if you can learn how to program, you can learn how to write a comment. I'm pretty sure that's a pretty safe bet there. So I just won't waste your time on it. So random, oh my goodness, there's a bunch of fun stuff. Choices, cool things, uniform, triangular distribution. I don't even know what that is. Math folks, what's a triangular distribution? Do we have a math major in the room? Should we hit the Wikipedia page? It's okay. I don't mean to put you on the spot. I'm sorry. I don't even know what this is. Oh, the normal distribution. Continuous probability with lower limit, upper limit. Why is this interesting? That's a lot. Business simulations, business decision-making and simulations. Not much known about the distribution of outcomes. Okay. If we can't use the, oh, it's not uniform. See corporate finance. Audio dithering. Okay, sure. I'm sorry, I'll just, okay. That was not worth it. You can get a Gaussian distribution, that's fun. Exponential distribution. Circular data distribution. Is that a gamma? Gamma distribution, not the gamma function. Like, how many times that's come up? This is like U2 V X Z R is BBB plus CCC. What even? Reading this stuff is obnoxious. UBP BU XP. Okay, p values are pretty common, right? But where's like randint? Okay, we'll just search. We want randint. There we go. Random integer from A to B, including both endpoints, is random range A plus B1. So we can use rand range. Let's go find that one here. Rand range. That includes a start. Stop is optional. Interesting. And a step. You can give it a step if you want here. So give it a start. If there is not a stop, we don't stop. Okay, that's fun. Sure. If what? I stop, a width, I step is 1, width, sure. Non-unit step argument supplied. I start plus I step times the rand below a given n. So whatever your starting value was, right? If you want to start with 10, right, we're going to start with 10 plus, and then whatever the step is, how big that distance is. Pick a random number, random below a certain value. Was that fun looking at the random module? Sorry, I think we spent too much time on that now. But that's a module. It's just a Python file with a bunch of stuff in it. And we import it. We say, hey, I want to import a module. So it will go look for modules that are named random. It's got a certain sequence that it looks at when we look at modules here. It's going to show me somewhere here, which is interesting. Use our import a module. We've done that. Yeah, we've done all that. Finding modules, this is it. So it will go look in the directory where the script is executing. That's where it's going to look first for a module. Then it's going to go look for the list of directories specified by Python path. You can set this as a particular path value here. I don't think I have anything set for Python path. Python path. I think I have anything. No, I don't think I have one. So you can set one if you want to do fun things with Python path. here, and then it'll go look in the directory where Python is installed. Right? So you might have this environment variable that specifies things, that's the Python path, to say, hey, always go include these modules, just as a little shortcut. Generally, this is kind of ugly, because then like you have to go and set around a bunch of commands and things for it to run. It gets to be a little bit annoying. Yep. I'm sorry, so first checks for built-in. Yeah, built-in first. And then those are the ones that come pre-installed. Then it will go look for other places here. So importing random, it's going to find the built-in random first, which is nice. It'll get our random module. So if you want to make our own module here, we can make a, so I can take this cup class here, and we can move it into a module. So I'm going to go add a new file here. So we're finally going to deal with multi-files instead of just a single main. So I'm going to make a new Python file here. We'll call this cup. And I'll have my class for cup in the cup module here. So now if I want to use cup here, it doesn't know what cup is. So I can say, hey, I want to import cup. The problem is it still doesn't like cup here because cup is the module, not the class. So if I want cup, it's cup module.cup class, right? That gets to be a little bit annoying. So then we have those shortcuts. We can say from the cup module, I want to import the cup class specifically here instead of that import. So then I can just say, instead of the cup module.cup class, I can just say, here's the cup class, because we said, hey, I want the cup class from the cup module. So if you don't like typing module name dot, you can import it specifically here. Right? Gives you one option here, and that's like from random. We can say, or from random import randint like that, and then I can use, instead of random.sample, now it's just print randint 10. Or 1 to 10, right? Because I'm only using this function here. I don't have the whole module anymore, right? If we've imported it that way, but we probably just want to import all at random, right? We've been using random as the module name the whole time, right? Here's module name dot function, module dot function, same idea here. So I probably should have made this lowercase. That's my bad here. Let me rename that. Rename, refactor, rename. Let's call that lowercase c cup. To fit our convention a little bit better. There we go. Okay, now we have our cup. So we can make our own modules, which is really fun. Really fun. So you can, specify what you want to import with that from. Give the entire thing or just parts of it here. With a hashing module, that's fun from the hash library. You could do different hash values. Now we finally get to this thing. So you might have seen, and especially ChatGPT is good at the if name is not main, don't do this thing. I think our sample code gave us that as well here. If name is main, then you want to do something. So what this lets you do is you essentially get to hide code away so that it doesn't run. So in cup, notice there's no code that runs. The only thing we have is definitions. So I can't actually run the cup class, right? Or I guess I can, it just won't do anything. If I run cup, nothing happens. There's no code for it to run, because all of it is just, here's the definitions, right? If I put some code in here though, if we're, print hi from cup here, and I come over to main, and let's see, I don't actually need sample here, and we run this. Oops, where? I expected, I didn't cut the rest of my cup class out. Oops, my bad. I should have taken all of cup. There we go. Now we have all of, it's all tapped in too far. There we go. Now we have all of cup. Okay, main should be a little happier. Hi from cup. You see that? Because we imported cup. Well, Python's, when you get to an import line, essentially what's happening is it's going and reading that file. Like it will mostly like copy paste that file into this line. You're like, oh, here, grab everything from cup, stick it in this line. Or go read that file. And it found some code to run in cup. So as it went to import it here, it also ran this code, which is probably not what we wanted, right? We probably didn't want this to run unless we're running the cup file, right? So that's where we get the if under name under equals under main under. You say if name is main, now I want to run this code here. So now when I go and import cup, nothing happens. But if I run cup, stop, there we go, stop. If I run cup, now it runs. So what happens behind the scenes, there's a couple things that Python sets automatically. Whatever file is the one that you're running here is main. It sets the name to main. I don't really understand all the magic here. It's not, don't worry too much about it. So when you tell it run this file becomes the main file. And then we can check to see, hey, if the name is this main file here, I want to go do something. When you go and import, it's not main because it has not been imported. The name is not main at that point here, right? I think name will be something else at that point here. We can print name and see what it is. Let's do that. That'll be fun, right? From cup. Wait, isn't it? Oh, I gotta run this one here. Run. So the name here is cup. That's the name of the file here because we're importing it. Name is main when you're running that file. When you go to run this file, the name is main, not its own name. I don't know why, but this is our common convention. So you'll see a lot of this places here where people want to try and put some code but not really do anything with it unless they actually want to run it. I think it's ugly, and you just shouldn't have code in class files or modules. That's just my opinion. So if you want to have code in your class file, your modules, you've got to hide it under the if name is main, so it doesn't run when you import it here. Yes, that's the big takeaway. So you can go and do that here. So this one's fun. That actually takes us through like a little web crawler using this URL lib request, which is really cool. You can go through and go and send web requests out, but this is just a fake search. It doesn't actually go and search. Google doesn't appreciate when we spam things, and if like you go and find a link and then go to the next link and go to the next link and go to the next link, it's going to get upset with us sending out so many requests that fast. So that's why they send it to the fake one here. Does this actually go anywhere? No, I didn't think it does. Okay, yeah, it doesn't actually search. Yeah, they probably have a note about that somewhere. I think they used to go to the real search link here. Yeah, but Python's a lot of fun. You can do a lot of cool things with it. Reloading modules. This one, you can. I've never seen people have to do this here. But once it's loaded the module, it's been like saved, essentially loaded into memory here. You can go reload it if you want. I don't know why we'd need to, so don't worry too much about it here for that one. And then a package now is a level up. It's like a folder that has a bunch of modules inside of it. So it's a folder with a bunch of Python files. So you can import an entire package, which is just a folder, a directory here. So when we're building a very large program, we want to break things into smaller and smaller and smaller pieces here. This fictional game here might have a sound module or sound package that has a bunch of other modules, a module for music, module for effects, module for speech here. It's just a way for us to organize these things. So to import it, you give it the folder name, directory name, package name, dot module name. Right? So by convention, if your files are in a folder, that folder is now a package. So we can do that if we want here and make our own. It's not super exciting, but I can add a new directory here. Oh, I'm sorry, that's right, we can even call it a Python package. Be specific about it here. So here's our containers. And then we should put cup in containers here. And then what other containers we could have? We could have another Python file for, we had a cup, how about a mug, right? And then mug, then we'll define a class for mug, define init, init. There we go. This one has, again, probably the max volume is probably pretty similar here. I'll steal this one here. What else makes mugs special then? So mugs, self.hasHandle is true. I'll just make this one public for now because I'm feeling a little bit lazy. But sure, now I've got a mug, right? So I can import my entire container package if I wanted. And we just say import containers.cup and import containers.mug. Right? We can use that package name here as we go. So now this will be containers.cup. .cup. Oh my goodness. Containers package, cup module, cup class. So it gets to be a little bit long here. So these froms, like to specify, hey, I want this one specifically, is pretty handy. Once you start getting into these long, big things here. We're not going to do anything that large that's going to need packages for our purposes. So it'll be okay. but you can have all sorts of fun with packages. And then our standard library. We love the Python standard library. All sorts of fun things in it here. Cool things around operating system specific functions and helpers, because Python will run on Mac, it'll run on Linux, it'll run on Windows. They handle things a little bit differently. So the OS module deals with that for us here. So I don't need to be specific for Mac or specific for Windows. I can just ask the OS module to do the thing for me, which is nice. Copy is pretty handy. We'll use this next semester to copy objects. It's pretty fun. Time is good. Managing time is actually one of the hardest things to do in programming because of daylight savings time and time zones, and things are just crazy. Like, you'd imagine every day has 24 hours, but that's not true thanks to daylight savings time. Some days have 23 hours, some days have 25 hours. Not very many of them, but some of them do. Right? It's a nightmare. And then there's leap years to worry about, and just use the time module. Right? Smart people have looked at this and figured it all out. We don't need to reinvent the wheel with time. It's great. Date and time. Yeah, shuffling a deck. Look, we can build a bunch of cards here if you want, using the random module. Or shuffle, right, is fun here. Oh, they didn't even give suits to their cards. That was lazy. Could have done suits at least. Yeah. Man, we got through that a lot faster than I thought we would here. What are you going to do for Wednesday then? We could get started on the new stuff early, start on files earlier if you wanted, or we could leave files till next week and leave Wednesday for Project 3, because I imagine you haven't finished Project 3 yet. It's just a guess. Or we could take the time to do our Zybooks, right? I'm going to run my report here. Let's see. Why is it so slow? Come on. There it goes. Okay. We've not made a lot of progress in the Zylabs. Zylabs? What's more fun to say that? I say Zybook. Is it Zbook? Zbook? I don't know. Yeah, so we're getting there. So there's not labs, you'll notice, for inheritance recursion. So thankfully you don't have a lot of lab work for that one. It's a quick lab for Python for data science, not a whole lot of labs in this one here. A couple of them. They're pretty quick here as we go. So that week will be pretty light on labs. And then this one should have been marked as optional. Sorry, let me mark that as optional here. Need to go configure. I thought I marked that one as optional, because I don't want that one to show up for that for you. Okay, there we go. Marked as optional. That way it won't, for your scoring, and I won't even grab that chapter anyway, but there we go. Just got a couple extra things here, which is fun. Lots of extra labs if you want some more practice. I didn't even publish those though. Sorry, I can publish them if you want more labs. Basic graphics is really fun. We'll spend probably a little bit of time on this one, because that's a fun one when we get into that. All right, so Wednesday then, do you want to meet at all, or you just want to have the time for free? Free time Wednesday? What do you want to do? Free time Wednesday? Okay. All right. If you want me to come, I'd be happy to show up on Wednesday and we can chat. I can help you debug anything if you're having trouble with your Project 3. Just shoot me a message. So if no one messages me, I'll assume no one wants to meet. And we can always Zoom too. So that's an option too. Cool. All right, so we got our lab today. We'll work on exceptions for our lab, and then we won't meet Wednesday, and we'll come back next week, talk about Project 3 and the final project and files. Awesome. Thanks, folks.